Okay, on problem number 10, it says sketch the graph of the function. The function they give us is y all equals 4, tangent 2x. So remember the quadrantals, pi over 2, pi, 3 pi over 2, 2 pi become the x coordinates. If there's a number in front of x, divide each quadrantal by it. So I'm going to take pi over 2 divided by 2, I get pi over 4. And notice pi, just divided by 2, comes out to be pi over 2. 3 pi over 2 divided by 2 comes out to be 3 pi over 4. And 2 pi divided by 2, simplified down, becomes pi. So I'm going to go ahead and label those. So notice this right here when I label it. I've got pi over 4, then I've got pi over 2, 3 pi over 4, and pi. I put in my negatives, so negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Okay, once I'm done doing that, when you're getting with a tangent, you got to put in the asymptotes. They're going to happen at pi over 4, 3 pi over 4, then draw the tangent graph, which resembles the x cubed graph in algebra. So notice, here I've got my asymptotes, pi over 4, just draw them on in there. 3 pi over 4, just draw it on in there. And then again at negative pi over 4, and negative 3 pi over 4. And then you're just going to draw in your x cubed shapes as you're going from left to right. And that's what your graph will look like for the tangent. On number 11, the directions on number 11 says, find the amplitude and the period. So just remember, the amplitude is the absolute value of A, and the period is 2 pi divided by B. So remember your general form of your sine is y all equals a sine of bx, and the general form of y equals a cosine of bx for the cosine wave. So now notice that this is y all equals negative 4 sine, and I rewrite this so that I can see that number in front of x, which is going to be 1/6. So now that I've done that, all I have to do is just go ahead and remember that my amplitude is the absolute value of A. So here's A right here. Absolute value of negative 4, which is going to be positive 4. Now my period is going to be 2 pi divided by B. Well, here's my B, which is 1/6, so 2 pi divided by 1/6. 2 pi divided by 1/6, I flip and multiply, and that comes out to be 12 pi. So that is going to be my amplitude, it's going to be 4, and my period is going to be 2 pi. On number 12, number 12 says, the point given is on the terminal side of an angle in standard position. Find the cotangent, the secant, and the cosecant of the angle. So to do this, we're going to use our coordinate trigonometry. So by definition, sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. You can notice that correlates to SOHCAHTOA when you put down a coordinate system. Do the reciprocals. Cosecant of theta is r over y, secant of theta is r over x, cotangent of theta is x over y. You'll notice that they give us the x and the y value. X is 3, y is negative 1. We're going to use our Pythagorean theorem to find out what r is equivalent to. So substituting in the 3, I got 3 squared. Substituting the negative 1, I got negative 1 squared, all equals r squared. I get 9 plus 1, it's going to equal r squared. So r squared is going to equal 10. And so r is going to equal the square root of 10. Okay, now that I have that information, now I've got this right here. So I've got the x is 3, the y is negative 1, and r is equal to the square root of 10. So by definition, cosecant of theta is r over y. So that's going to be the square root of 10 all over negative 1, which simplifies to negative square root of 10. Secant of theta, that's going to be r over x. So r is the square root of 10, x is going to be 3. And so that doesn't simplify, it's just going to end up being the square root of 10 all over 3. And then your cotangent of theta, well, your cotangent of theta by definition is x over y. So here's my x, here's my y, I substitute them in. So x is 3, y is negative 1, simplifies down to be negative 3. Okay, number 13 says identify the quadrant in which theta lies. So here's our definitions. It says cosine of theta is less than 0. Cotangent of theta is less than 0. Well, to answer this question, we have to do our chart again. So on our chart, First quadrant, sine, which is y, is positive. Cosine, which is x, is positive. Tangent, which is y over x, is also positive. Second quadrant, sine is positive because it's the y value. Cosine x value, that's negative. Tangent is negative. I like to write the reciprocals, cosecant, secant, cotangent, because they take the exact same values as the sine and cosine. Third quadrant, sine, which is y, is negative. Cosine, which is x, is negative. Tangent is y over x. Sine over cosine, negative divided by negative is a positive. In the fourth quadrant, sine is negative, cosine is positive, tangent is negative. So by definition, that we just read right there, cosine is less than 0, that means cosine is negative. Cotangent theta means cotangent is negative, so it's reciprocal, tangent is also negative. So our job is to find the quadrant in which cosine is negative and tangent is negative. This meets the criteria for the second quadrant. So look at the second quadrant, both cosine is negative, tangent negative, and that's the only quadrant it happens in. So we're sitting in our second quadrant, and so that is going to be your answer, is quadrant 2. Okay, number 14. Another story problem here. It says a 20-foot ladder makes an angle. And we'll go back and take a look at this off of our review sheet here. We'll read through it together. So number 14 says a 20-foot ladder makes an angle of 42 degrees with the ground as it leans against a wall. How far up the wall does the ladder reach? So then when you look at your solution guide, just a reminder, draw a diagram involving the given information, form a right triangle, and then use the trig ratios formed by SOHCAHTOA to solve the problem. So remember, on SOHCAHTOA, here's our ratios. So sine of theta is opposite over hypotenuse, cosine of theta is adjacent all over hypotenuse, tangent of theta is opposite over adjacent. So I go ahead and draw a shape here. It says that this ladder is leaning against a wall. So here's my wall right here. And then it says that the ground, it says that where you are, 20-foot ladder. So here's our 20-foot ladder. Here's our ground. And it says that the ladder makes a 42-degree angle with the ground as it leans against the wall. So notice that this matches SOH. Sine theta is equal to opposite over hypotenuse, because as I'm working from here, here's my opposite, and here's my hypotenuse. So we can set up a trig ratio involving that given information. So that's what we do right here. So underneath here, we're going to write down the sine of 42 degrees, because that's theta. X, which is the opposite side, which is what we're looking for. And that's going to be all over the hypotenuse, which happens to be the length of the ladder, which is 20 feet. Multiply both sides by 20. And you get 20 sine of 42 all equals x. Just take your calculator. Make sure that you are in degree mode. Once you're in degree mode, you can just go ahead and type it in exactly as you see it. So we're going to type in 20 times the sine of 42. Once you're done, just go ahead and hit enter. And it looks like your answer comes out to be 13.38 feet. That's how far up the wall the ladder reaches. Okay, number 15, it says that use the properties of inverse functions to evaluate the expression. The secant of the arc sine of 3/5. We'll go ahead and use our coordinate geometry, coordinate trigonometry on this one. So it says use the coordinates that correlate to the trig functions to solve the problem, and the Pythagorean theorem. So notice sine theta is y over r, cosine theta is x over r, tangent theta is y over x, cosecant theta, reciprocal r over y, secant theta r over x, cotangent theta, x over y. So the sine that is given to us is y over r. So notice, make note of that right here. 3 is the y, 5 is the r. I got to go ahead and find what the x is equal to, because I want to find the secant of it. Secant is r over x. So using my Pythagorean theorem, x squared plus y squared equals r squared. So x squared is what I'm looking for. 3, which is my y, is 3 squared. 5 is my r, which is 5 squared. So I got x squared, 3 squared is 9, 5 squared is 25. Subtract 9 from both sides, I get x squared equals 25 minus 9, so x squared equals 16. Take the square root of both sides, and I get x equals 4. So now that I know that x equals 4, I can just go ahead and fill this in, because the secant is going to be r over x. So r is going to be 5, x is going to be 4. So here's my r, 5. Here's my x, 4. So your answer is going to be 5/4. Okay, then on number 16, it says, in which quadrant of the terminal side of the angle theta? This is that theta is equal to 13 pi all over 4. Well, there's two ways to figure out which quadrant 13 pi over 4 ends in. You can change pi to 180 and solve it, or you can change 13/4 to a mixed number. After changing, follow the unit circle using either degrees or radians to see where the angle ends. So I went ahead and demonstrated this both ways. So this first way, I went ahead and changed pi to 180. So I took 13 times 180 divided by 4, and I got 585 degrees. So if I do it that way, I just got to go ahead and go around the entire circle. And notice that when I go around one time, that's 360 degrees. So I went ahead and took 585 minus 360. And so you're going to notice that when you go around that entire unit circle, you're going to go around 585 times. So when we go around this, we end up right here, back there again. So that leaves us with 225. So now rotating 225, so there's 90, 180, 225. That's going to put you in the third quadrant. You can do the exact same thing if you want to with 13/4. So 13 pi over 4, I'm going to change that to 13/4 pi. And 13/4, well, 4 goes into 13 3 times. That's 12 with a remainder 1, so that's 3 1/4 pi. So notice, if I go around my unit circle, here's 1 pi, here's 2 pi, here's 3 pi, and then I'm going to rotate back down to another fourth. That's going to put it right there in the third quadrant. So notice my answer is going to be in the third quadrant. So I forgot to write in a little extra slash here, so I'll put it in. So we are sitting in our third quadrant. So that's going to be the answer to number 16. So number 17. Says it wants to find the exact value of 7 pi over 3. So we're going to use our reference angle. So sine of 7 pi over 3. Reference angle, you can just ignore the 7, and you'll get sine of pi over 3. And we're going to find its answer. So notice, we're going to need our chart here. So just as a reminder, here's our first chart. First column, you can write down your degrees. You got 0, 30, 45, 60, and 90. Second column is going to be radians. That's pi over 6, because 180 divided by 6 is 30. Pi over 4 is 45, because 180 divided by 4 is 45. Pi over 3, 180 divided by 3 is 60. And pi over 2, 180 divided by 2 is 90. Then remember, this is the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2, which all reduce down to 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Cosine goes the opposite of it. So square root of 4 over 2, which is 1. Square root of 3 over 2 doesn't simplify, so that's square root of 3 over 2. Square root of 2 over 2, square root of 1 over 2, which simplifies 1/2, and the square root of 0 over 2. And when I take 0 divided by 1, I get 0. 1/2 divided by the square root of 3 over 3, I flip. The square root of 3 over 2. 2's cancel. Rationalize, get the square root of 3 over 3. Take the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. Square root of 3 over 2 divided by 1/2. I flip the 2's cancel, get the square root of 3. And 1 divided by 0 is going to be undefined. And then just remember your other chart. We've been through this other chart where all the sines and cosine values are located at. So I'm going to go ahead and find the sine of pi over 3. And when I do that, I go to the sine of pi over 3. And notice that is going to be the square root of 3 all over 2. Once I've got that answer down, then I have to find out if it's positive or negative by finding out where 7 pi over 3 ends up in my quadrant. So remember, 7 pi over 3, same thing as 2 1/3 pi, because 3 goes into 7 twice. So that's 2 1/3. So all I have to do is go to 2 1/3. So here's 1 pi, here's 2 pi, here's 1/3 of another pi. So it's in quadrant root 1, and the sign is going to be positive. That answer is going to be the square root of 3 all over 2. Okay, then on this last problem, let's find the exact value of all 6 trigonometric functions at a given angle. So notice, again, we're going to use our right triangle trigonometry, so Kato with the Pythagorean theorem, a squared plus b squared all equals c squared. So notice this right here says, this triangle, here's 5, here's 13. I'm going to go ahead and use the Pythagorean theorem, a squared plus b squared equals c squared, so I got 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. I subtract 25 from both sides, get b squared equals 144. Take the square of both sides, and once I get the square of both sides, I'm going to get b equals 12. So now I can go ahead and fill in my triangle. So here's my triangle. I've got hypotenuse is 13, opposite is 12, adjacent is 5. Remember, sine is opposite over hypotenuse, cosine is adjacent all over hypotenuse, tangent is opposite over adjacent, cosecant is hypotenuse over opposite, secant is hypotenuse all over adjacent, and cotangent be adjacent all over opposite. So let's go ahead and fill in those numbers right there. So notice again, let's make this a little bit smaller. So notice sine, opposite all over hypotenuse. Its reciprocal, cosecant, would be hypotenuse all over opposite. Cosine is going to be adjacent all over hypotenuse. So 5 all over 13. Secant would be 13/5. Tangent theta is going to be opposite all over adjacent. So here's opposite, here's adjacent. So 12/5. Cotangent is going to be 5/12. And that'll be your answer to number 18.